In the next 8 minutes, you are going to make a program that controls the speed of this DC motor using this potentiometer. Hi, my name is Jeremy, and welcome to the 6th tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid-State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos as this one will build on their material. Electric motors convert electricity into kinetic energy. There are many types of motors, including DC motors, AC motors, servo motors, and stepper motors, to name a few. In this tutorial and the next, we will be working with both DC motors and servo motors. DC motors are commonly found in tools, toys, and household appliances where the rotation speed must be controlled. On the other hand, servo motors are commonly found in RC planes, robots, and anywhere where the rotation angle must be controlled. A DC motor only has two connections, typically colored red and black, corresponding to the positive and negative sides. Connecting the positive side to 5 volts and the negative side to ground will spin the motor at full speed in one direction. Reversing these connections will cause the motor to spin in the opposite direction. However, this circuit is rather boring, as the Arduino has no way to control the motor. Instead, we might consider connecting the positive side to one of the Arduino's digital outputs. Setting this output high should turn on the motor, and setting it low should turn it off, right? Yes, but this is not recommended, as the port cannot output enough power to run the motor at full speed, and you risk damaging the board. Instead, we will get the Arduino to control an external switch which will be responsible for enabling and disabling the motor. This switch is called a transistor. Transistors are devices that operate much like our push button from tutorial 2. However, they're controlled electrically. Generally speaking, there are 4 types of transistors: NPN, PNP, NMOS, and PMOS. These can be classified as either bipolar or MOS, and standard or complementary. You can distinguish a bipolar from a MOSFET based on the 3 port names. They will either be called base emitter collector for bipolar, or gate source drain for MOSFET. For all intensive purposes, there is little difference between the two. Within either group, there are 2 variants, either standard or complementary. This designation determines how the transistor behaves when a control signal is applied to either the base or gate. If we connect the emitter or source to ground for standard transistors and 5 volts for complementary ones, then setting the control signal to 5 volts will activate the switch of standard transistors but deactivate the switch for complementary ones. Setting the signal to 0 volts will do the opposite. As such, we see the complementary nature. When one is connected, the other is disconnected, and vice versa. Let us add this to our circuit. In this case, we will use either an NPN or NMOS transistor, where the base or gate connects to a resistor of around 250 ohms, leading to our Arduino. For additional protection, it is recommended placing a diode in the reverse direction alongside your motor. Use this diagram to ensure you place the diode in the correct direction. Now, by setting the Arduino's output to 5 volts, the motor will spin at full speed, and by setting it to 0 volts, it will stop. This is great and all, but say we also want to control the motor's speed. It turns out we can use the same PWM signal we learned in our last tutorial to do exactly that. If we send a PWM signal with a 50% duty cycle, the motor will spin at half rate. Lowering the duty cycle will slow the motor, stopping it completely when it reaches 0%. On the other hand, raising the duty cycle will speed up the motor, achieving full speed when we reach 100%. Pretty cool, right? Let us build this circuit. Make sure to unplug your Arduino to avoid damaging any components. Next, rebuild the analog sensing circuit from tutorial 4 using a potentiometer with one side connected to 5 volts, the other to ground, and the middle to one of the Arduino's analog inputs, in my case A0. Then, take your DC motor and connect it to the breadboard as shown. Connect the positive side to 5 volts and the negative side to the collector or drain of either an NPN or NMOS transistor. Connect the emitter or source of the transistor to ground and the base or gate to a resistor of around 250 ohms leading to one of our PWM outputs. I will use port 3, but you may use any of these ports. If you are unsure as to which transistor port corresponds to which of the 3 connections, do a quick Google search using the part number to find the component's datasheet. Datasheets contain all the information you will ever need on a given component. Finally, for added protection, add a diode pointing towards the positive side of the motor. Next, let us write the code. Today we will combine the code from tutorial 4 to sense the rotation of a potentiometer with the code from tutorial 5 to create a PWM output. Begin by defining both the input and output ports, in my case A0 for the analog input and 3 for the PWM output. Then in the setup function, initialize these ports as either input or output. Type pin mode input port input and pin mode output port output. To read the potentiometer, in the loop function, type int val equals analog read input port. Then to set the PWM output, type analog write output port val. Add a small delay with delay 50. Now we're not quite done yet. If you recall, the analog read function outputs an integer anywhere from 0 to 1023. However, our analog write function expects an integer anywhere from 0 to 255. As such, we must convert from a 1024 scale to a 256 scale. We can do so by either dividing our value by 4 or using the map function. Between the write and read functions, type val equals map val 0 1023 0 255. This is a built-in Arduino function with 5 arguments and 1 output. The first argument specifies the variable we would like to modify. The second and third specify the current range, the fourth and fifth specify the desired range, and the output is the modified variable. Plug in your Arduino and upload the program. If successful, by rotating the potentiometer, the speed of your DC motor should vary. If so, then congratulations! Feel free to play around with the DC motor. I challenge you to come up with a circuit that not only controls the speed of our motor, but also, with the flip of a switch, its direction. Join us next video when we will learn to control this servo motor.